Hello and welcome to Objective-C Programming lecture number 7. The single purpose of this lecture is to make sure you know how to do undoes and redos in your application. And this is module 1. So you probably know what undo is that magic combination that undoes something that you did and want to get back. It's usually Control-Z or Command-Z in Macs, and any good application allows user to do this. An even better application allows the user to redo actions. So if you undone something and you actually don't want to undo it, you want to go back to what you had before so you can get the step forward. And unfortunately, the real life doesn't have that, but I guess it's fine. You can implement this mechanism by yourself, and most of the time, it's not that complicated. You just have to get the idea. But we are lucky because we have all those wonderful things that come with Objective-C and come with Xcode, that come with all those frameworks in OS X, OS X, and we can take advantage of NSInvO Manager, which allows us to make undos and redos really easy. The idea behind undos and redos in general is you want to remember all the changes, because if you want something to be undone, you have to know what it was. So you have to remember all the changes that happened to your model, to the application, to the data. The changes are the results of messages. So if something happened to your application, that means there was a message doing something. So actually you don't want to save the results, you want to save the messages that caused those results. So you want to actually save messages. But the problem is messages are actions, they are calls, they are not objects. You cannot put a message in an array or something unless you convert it to an object. This is not real conversion. It's not like you can convert a float into integer and you can convert the message into an object. No, but you can use something to put this, to save this message somehow and represent it as an object so that you can pass this object on, you can save this object, you can do stuff with this object. And luckily, we have another thing that starts with NS, and usually things that start with NS give you something wonderful. In this case, we have NSInvocation, and as well as NSInvO Manager, it comes from next step. This class allows you to save a message, meaning everything about this message, this selector, the name of the message, the receiver, the object, or actually the pointer to the object that this message is supposed to go to, and all the arguments that were sent with this message into a single object. So you pack this whole thing into an object, and you can save this object. This is just like any other object. And one of the reasons this thing exists is there is a thing in this language which is called message forwarding. And this is exactly what it says. You probably know about this notion. You have these things in your phones, in emails. You can forward a message to somewhere else. In real life, with emails, for example, if you got the message, that's it. You got the message, but you can also forward it so that exactly the same message gets to somewhere else. In Objective-C, the idea of forwarding is right like this. If you are an object and you get a message and you don't know how to react to this message, you don't have a method of the same name, usually the idea is you want to raise an exception because you don't know what to do. This was probably a mistake. But before raising an exception, the messaging system checks if you, the object, have a method called forward invocation. In other words, it checks if you, by any chance, have some ability to forward the message you don't know how to understand to somewhere else. So if you do have this method, the exception is not raised, and the message is being forwarded. Actually, this method is being called, and whatever you put in that method will be implemented, will be run. Idea is, if you don't know how to react to the message, you probably might know someone or something that can react to this message. But if you don't have this method neither, if you don't have ability to react to the message and you don't have a method called forward invocation, then you don't have any other choice. You have to raise an exception because you just cannot react to this message in any way. So remember our application from the last lecture. We had this program with a table and 2 buttons, and we could create a new employee, and we could remove an employee from the table, and you could change the name of the employee and the raise, the expected raise in salary. So suppose your user runs your application and does 3 things. It adds a new entry, it changes the name from unnamed person to Jon Snow, and it changes the expected raise of Jon Snow from default 30 to 20%. So if you have NSInvocation manager working behind the curtains, you will see something like this. You will see 2 stacks. One stack for all the messages that you want to undo, you might want to undo actually, and the stack of redo messages, of all those messages that you undone but want to go back. So when the user hits the first button and creates a new entry, the message that was used to create a new entry is also used to create a new NSInvocation object. And that message is packed, but not that exact message, the inverse of that message. Because if you added something new and you want to undo it, you have to remove something new. So you need to create an inverse of that method and save it into undo stack. And this is what it is. The first thing is here in undo stack is the NSInvocation object, which is a message, delete record number 1. Then the user changed the name from unnamed person to Jon Snow. And inverse of that action will be changing the name back to unnamed person. So another message is generated and saved into an NSInvocation object, and the method it's changing the name of record 1 to unnamed person. And the same with the raise. The user changed the raise to 20, but default is 30. But rather, not the default that matters, but what was before 20. And before 20, it has 30. So this third object here is an NSInvocation with the message packed inside, which changes the raise back to 30. So user did these 3 things, and then it decided to undo the last one. So the user hits Ctrl Z or chooses Edit Undo from the main menu, and then another message is put into redo stack, and that last message is removed from undo stack because, well, it's no longer there, it's undone. The redo stack should be the inverse of that undo message, or the original message that was fired the first time user changed the raise of Jon Snow. So we have the inverse of that function that we used in undo in redo stack, and it's set raise to 20%. And then the user hits undo again, and another message gets deleted from undo stack, and another message gets pushed into redo stack. So in undo, we're changing the name back to original, and in redo, we're changing the name, we can say changing it forward to Jon Snow. And then we hit undo again, we could do this add new record. From this point, you have everything visually as if you just run the application. You have empty table and no employees in your array. It's not just the table, it's not just the visual, it's of course the model itself. There are no entries in the array. But you have something in redo stack, and you can redo this all. And this will just make everything go back. You hit redo 3 times and you get back to this. So it's quite logical, right? It's obvious. So NSInvocation manager keeps track of both stacks and adds and removes items automatically. So you don't have to worry about those stacks. You don't have to worry about memory and calling those stacks. The only thing that you need to do is provide with inverse invocations. So you need to give NSInvocation those inverse functions so that when something happens, it puts the inverse into undo. So simple example is here. You have a function that makes the temperature go up 10 points. So you change the temperature, of course, but then you have to say, hey, undo manager, the inverse of what I just did is this method. And we are saying here, undo manager, prepare with invocation target self. So the target of that invocation, the target of the method that should be called when you want to undo is me, it's self, it's the object where this happens, the instance. And then I pass the name of the message, the name of the method that should be called if I want to undo this action. And then, of course, I have to provide to implement this same method. So here's the method, make it colder. And obviously, it does -10 to the temperature, is the inverse of this. And of course, I have to do this again. I have to say, well, to undo this, I have to call make it hotter. Now, NSInvocation is really smart because even though they look the same, if you hit make it hotter first, then this will be undo. But here we have the same line, but of course calling the other method. It knows which is undo and which is redo. So if I want to redo, even though this is the same undo manager, this method will be called if I want to redo after that undoing. So there's no redo NSRedo manager, it's all called NSInvocation manager, and it keeps track of both undo and redo. So all those invocations are grouped by event. So if one single user action makes multiple things change, then all those changes will be undone by a single undo. So if you have a button which changes multiple labels, then undo will change all those labels back because this was a single user action. Also, most of the applications we write are visual and they have this thing called main menu. It's that menu on the top. And that menu has default items like file, edit, window, etc. In the edit, we have that undo and redo, and all the applications we were building before, if you try to run undo, you wouldn't succeed because those items are disabled. You cannot do undo. But if we have undo, we will be able to call them, to click on them. By default, they all just called undo and redo. And the good application also tells you what action are you about to undo if you go to that menu. So a good application will say undo edit or undo delete item something. So we can add that action name to the menu by doing this, undo manager, set action name, and then something that will be added to undo or redo. And we will see the example of how we do it in the following modules. Thank you. Welcome back. This is module 2 of lecture 7, and this is where we will use the information we just got and implement undo and redo in our application. So you usually have to create a new NSInvocation manager, but since we created a document-based application last time, we already have NSInvocation manager in NS document, so we'll just take advantage of that. Before we go on, we have to understand something. Remember key value coding concept, the idea of getting the value of some variable and setting the value for some variable using its name. Remember last time it sounded kind of obvious and stupid, but now we will actually get into it and see how this helps us do undos. Now, when you design your class and you create a new variable, you create instance variables, you have one of 4 possible purposes for that variable. It could be a simple attribute. It could be something which is represented by a simple data type, like a number, a string. So in our example last time, the person had a name and a race. That is just a string and a number. that is a simple attribute. You could also have a variable which is to one relationship, meaning it's a complex attribute. It's something that still points to something single, but that something single is not just a value, it's another object. It's a pointer to another place in your application. You could also have a variable that represents ordered to-many relationship, meaning you have an array, for example, which is a set of pointers to another objects. Those objects could be simple or complex, but you have this ordered relationships in your application represented by a single variable. And in the same way, you can have a single variable that is to many relationships, meaning it's the same as array, and you could have some order, but it's not inherited in your application. So you remember last time we were discussing NS set or NS mutable set, and that is the data type for sets, unordered collection of things. So those are four possible purposes for your instance variable in a class. We discussed how to use key value coding for simple attributes and those that represent to one relationship. So for those attributes that you use to point to single thing. The key value coding looks for accessors for those get value and set value things and uses them. And if we create accessors for to many relationships, then that accessor will be used if a value being changed or set if we get the value or set the value using key VC. So here's an example. Suppose you have a playlist, and this is just an object that represents a playlist. And of course, in the playlist, you have maybe an array of songs, and song is another object. So you have an S mutable array. If we want to use key value coding and key value observing for manipulating the array, we ask the playlist for mutable array value for key. This is the name of the method. And get back the proxy object. And proxy object is something that will represent the thing that we ask for. So here's an example. We create a new object and we don't have a class for it, so we say ID array proxy, and we ask the playlist for mutable array value for key songs. We know that we have this array called songs, but instead of just getting that array, we are getting the array value for this key, and the key is of course the name of the variable. We know that the name is songs, and we get another object in return. We don't get the array itself. We get the array proxy, which is like an agent for that array. And after, if we want to talk to this array, we have to talk to his agent first, and the agent will talk to the array and get something for us. So the next step, we want to get the number of songs in our array. So I asking my array proxy count, and count is a simple method in array itself, but this is not an array, this is the array proxy. So what happens is, if I ask for count, the proxy object, this array proxy, will ask the playlist, because this is a proxy from this playlist, if it has a count of songs method. And this is not just in this example, this is actually the name that will be used if I ask for count and the array is songs. This name will be generated, count of songs. So if playlist does have this method, then this method obviously will be called and we will get back the result, something that this method returns. If there is no such method, the playlist will get the array of songs, the actual array, and ask the array for its count. And again, the naming the method count of songs is not just a convention. This is the key value coding mechanism and this name is generated by that mechanism. So if you had not songs but books and you asked for min, then the method that will be called first will be min of books. So if we want to get the number of songs in this example, we might want to implement this method in our playlist, knowing that it will be asked through the array object. So this is how it works. We have an array proxy, so we got that mutable array value for key songs, and we get the proxy for that array. And asking it for a count is the same as asking the playlist for count of songs, because this will just call this. And asking the proxy of object at index 5 will be exactly the same as asking the playlist and calling it method object in songs at index 5, if this method exists, of course. And the same thing with everything else. If we want to insert object, this is the same as asking the playlist to insert object in songs at index. So if we're using key value coding, we could just implement those methods because we know what those names will be, because we know the name of the messages that will be sent, and we know the name of the object of the array in this example that we have. So we can construct those methods before, and those methods will be called every time something gets or tries to get an object from that array, or tries to get the count of that array, or tries to remove something from that array. So we can implement methods for all those things that will be called using key value coding. So it's exactly the same for those relationships that are unordered. So if we have an NS set of, in this example, students, it's exactly the same. But of course, those methods that are possible for set will be called. Something like get object at index is not possible because set doesn't have indices. But the idea is the same, and the naming, the construction of the names of the methods is the same. This is really, really important. This is a powerful mechanism, and you have to understand this. So in this picture, you could see, so we have the playlist, and first thing, we got the proxy for this array of the playlist. So we have now this proxy, and we're talking to this proxy. We don't talk to the playlist, or we don't talk to the mutable array. We ask the proxy for count, and that will first check if the playlist has count of songs, because count is the name and songs is the name. We could, of course, call the playlist itself and ask it for count of songs. This is okay. And if it doesn't, then it will check the array of that name and ask that array for count. And exactly the same here. Okay, so how to use this in our application? We have an array controller. Let's just go back to the application, actually. We have this array controller, and we've bounded content array to the employees array in our document. So we use this array controller to connect to the actual data, to connect to the array of employees in our document. Array controller uses key value coding to add and remove person objects. So we have this application and we can add and remove objects, meaning employees. What happens behind the curtains when we click that button, and remember we bound to this method add and this method remove to those buttons on the interface. Every time those methods are called, key value coding is used to get that array, not actually the array, but get the proxy for that array in our application and add the value or remove the value. So if we want something to happen when this happens, if we want something to happen when a new object is added or an object is removed, all we have to do is override those methods, or actually create those methods that I just explained. We know the names, so we can create those methods and do something in those methods what we want to do. The thing we want to do is add inverse messages to the undo manager. So this is what we're going to do. First, let's go to our header file of the document. Here, we want to use import. Want to use the person class. So let's import person header file. We have autocomplete. Now we want to add two methods. First is insert object in employees at index. And this is not the name I come up with. This is the name that is generated and will be expected by KeyValue coding. So it will be void function, insert object of class person, in employees at index. And the index is NSU integer. And the name is index. The error is expected after prototype, yeah, like this. And the other one is, of course, to remove object from employees at index. NSU integer index. So I know the name of this object, of this method, because I know that my mutable array is employees. So this is why it's employees here and here. Okay. Now, of course, we have to implement those. Let's go to my document.m implementation. And let's go back. You can see here we have the warning incomplete implementation, meaning we don't have those two methods implemented, which we will fix. Okay, first is insert object. We have autocomplete. This is nice. And like this. As I said, we have an NSInVo manager, but we have it in ourselves. Let's get it using NS. Oops. Let's create a new one. I mean a new pointer, of course, but use our undo manager what we have in self. And now let's give it the inverse of what we're doing. We are inserting, so we want to give it the remove method as something to be put in undo stack. So let's call undo. Prepare with invocation target self. We want to do it on ourselves. And the name of that function will be remove object from employees at index. Of course, we have the same name index. Now, I want to say this. If I'm undoing, I want to set the name of that action so that it is updated in our menu. So let's say undo, set action name, and just say add person. So we inserted a new person, and if I want to undo it, the menu will say undo add person. This is all fine, but we should not forget to actually do it. Now we should remove the person. Oh, I'm sorry, add the person. So employees, insert object P at index. Okay, ready, one to go. Now, almost the same method. So this is bad, but I'll just copy and paste. No, there are always mistakes if I do it. So I say remove object from employees at index, and I want to create a new person, because if I want to save something, if I remove a person and then want to undo, I have to save this person so I can get back to it. So I'll get that person that we about to remove from our array, because we know the index of that person. So now I want to tell the undo manager, please. Oh yeah, I have to get the undo manager like this as well. So this is okay to copy paste. So undo, prepare invocation with target self. And now we have to say insert object. So that the name of the method that we just created. Insert object P, the person we just saved from dying, and index. So I'll just copy and paste this as well and say this would be remove person. So if I remove this person, I want the menu say undo remove person. And of course, removing itself. Employees, remove objects at index. So this is it. Let's run. If I click add new and go to edit, I have this undo add person. If I click it, we'll undo. No, we have an exception. So let's see. Uncode exception was raised, insert object called. Okay, well, something is wrong. Let's just check. Okay, insert object in employees at index, undo, prepare, remove from employees at index. Index is undoing, and person at index. Oh yeah. When I was escape typing here, it said insert object at index, but actually I wanted to call this insert object in employees at index. This is the name that should do it. Let's run this again. Okay, add new, edit, undo, undone. And I can redo, this will add it back again. I can do multiple things and like this. And I have Command Shift Z, this will redo. So I can do undo, reduce, really nice. Okay, it works. Actually, this is not all I wanted to do. Adding and removing is fine, but this was an easy part. The tricky part is if I want to undo and redo all the changes that were done here. Because if I type something here, this won't be saved. And if I undo, only the insertion and deletion will be saved. So I just lost that. Okay, the next module will talk about how to do that. Welcome back, this is module 3. Let's add undos for all the textual edits in our application. So first thing you have to remember or just recall is the KeyValue Observing. It's a mechanism for informing objects when value of some other object is changed. We want our document to be informed every time the name of the person or the race of the person is changed. So we want to observe those values and do something when they do change. Luckily, we have something in NSObject again. We have the method called addObserver, and it expects the observer, the object that will be observing a value. Then it expects the key path, and this is exactly like in key value coding and observing. This is the string, which will be a path that represents the name of the value that we want to observe. Then we want to pass some options, and those could include something like, do you want to get the old value as well? And the context is something else that you want to pass with this message. So when change does occur, the object that was observing this change will get a call of this message. Observe value for key path, and then the key path of, and then the object, and then the actual change and the context that was passed. So we want to take advantage of this, and we want to look for, observe those values that we want to undo and redo, and again, do something when those values actually change. So we're back to our document.m, and I'll just make this because this will be actually the only place we will have to make changes. And let's go to the beginning. Okay, so first thing I want to add is something for the static, for the context. We want to have a context to be passed, so I'll just pass something empty. I'll say a static void rm document KeyValue Observing context, and we'll just use this. Okay. In the implementation, we have to implement start observing person method. So this will be a void method. And it expects, of course, a pointer to a person. And since person is inherited something from NSObject, we can say person, please add observer. An observer is self, because this is where we are, and this is the object that we want to be the observer of this person. So self, for key path, we have the name. This is the name of the person. For the options, I'll just use NS key value observing option old. And let's just skip this for now. And the context is the address of that pointer. So rm document KVL context. Okay. So we just told the person that we want us to be the observer of it, of the person. This is just for the name, and I want to actually observe. So I'll just copy and paste everything, except that I want, in this case, to observe expected race. And this is a string, so I'm typing it and the system doesn't know what it is. It thinks it's just a string, so I can just type anything. It won't complain when I compile. It will not complain when I click this. This happens, it will just not see this key and this key path, and nothing will happen. So be careful, and probably the best way is to recheck and go back to person and get that name, just copy and paste it here, and the name seems to be okay. So that we don't make mistakes, because this is really hard to debug. Okay, this is start observing. We need to stop observing at some point. So let's implement stop observing person. And it's the same idea, we have a person that we take as an argument, and for that person we want to remove observer. Self for key path, the name, and same stuff here. No, I don't think it's the same. Probably, yeah, of course we don't have options because we're removing an observer. And let's do the same for expected raise. Just copy and paste here. Okay, so now we have those methods, so we can start observing a person and stop observing a person. And by observing the person, we actually observe both values of the person that we want to observe. So you can observe an object, but not the whole object, only those values that you want. And you have to name the names, you have to know the names of those methods. So now we want to start observing persons at some point. And a good place to start observing a person is when you just inserted it. Remember in the last module we implemented insert object. So before inserting, let's start observing it. So let's call self start observing a person, and that P is here. And of course, when we remove the person, we don't want to observe changes for that because no change is actually possible. We have that person saved though, because we have this undo. But let's call self stop observing person P. Okay, another place to start and stop is when we set employees, because we didn't really use this, I think, but we have this function which takes another array and just replaces all the employees with this array if they are not the same. So if they're not the same, I want to stop observing all the employees that I'm about to lose because I'm not going to use them anyway. So let's create a new for loop, and this is where we use that fast enumeration that we covered in the last lecture. We say for every person, which is a pointer to person, in employees, I want to call self and stop observing that person. And then I replace the array. Now I have a brand new array that we just got from this A, and I'm not following any of those. So I want to do the same, but start observing every person in that new array. So for every person in employees, I want self start observing person. Okay, almost there. We need to add two more functions. First is like this. I want to change the key path, and we will use this when we actually observe the change and do the change. So it's kind of a generic method I want to have and use. Change key path, and it takes NSString called key path. So I want to change the key path of object, which is ID obj, to some new value. And the new value is another object. And that is actually quite simple method because I want to obj set value, the new value. Oh, of course not new object, this would be stupid, new value. So that for the key path that I got provided, key path. So now I can pass any object and change its key value to something new. It's the value of the key I just passed. So now let's implement the method that will be called when the name of the person or the expected raise of the person is changed, because since we are observing that, the observed value for key path will be called. Remember, this thing will be called when change actually occurs. So nothing will happen if we just run it like this. We just won't see any change. We will be observing changes, but we won't react to those changes in any way. So I have to implement observe. We have a escape here. Observe value for key path of object, then the change, and the context. So first, we have to check if the context is the same, because if it's not the same, then probably this observing reaction is supposed to go to our parent. So let's check if context does not equal to the address of rm document KVL context. Then let's just call the same function for our superclass. Observe value of the key path, of course. So just pass everything up. And this is object, and change is change, and context is context. Okay. Let's get our undo manager again, because the only reason we're doing this, we're observing it so that we can save it, so we can undo it. So NSInvocation manager, so everything we did before in the same manner we're doing here. Undo manager like this. Let's get the old value, and old value equals the value of the change object for key, ns key value change old key. I want to get something that was before the change. Now I want to check if it was actually something. So I want to check if it is equal to, and no change is represented by NSNull. And NSNull is a class, so we have to create a new object, a new instance of NSNull. And we have a method, the class method of NSNull called null. This will return a brand new null object. And I have to say the old, yeah, of course, here, the old value. If it's null, I just have to say it's nil, because nil is what's used, a simple nil. Okay. Now let's actually do our undo, and it's exactly the same way. We have to prepare with invocation target self, because we're still doing it to ourselves, and then change key path, the key path of object. So everything we have here to value the old value. So we want to undo it and get it back to the old value. And to be nice, let's say the action name will be edit, any edit we did to the text. Okay. This should do it. Let's try and run. Okay, I add a new thing, and now let me rename this to Jeremiah Joha. And if I command Z, this is back to unnamed person, and I can redo it, redo edit, Jeremiah Joa, and the same should be here. I get it to 67, I edit undo 30, and I can redo 67. Voila, that works. All right, this is it for this module. And this is actually it for the lecture. So this wasn't too exciting, but this is really important. I can't think of an application, except for a game maybe, that where you don't need to have undos and redos. And I actually just got an exception here. So there is probably something bad happening. So we will check about this on the next lecture. You can observe it. And thank you. Bye-bye.